A very good morning to all. Warm welcome for the virtual lab demonstration session. So, on behalf of GoI Engineering College, we welcome the experts from National Institute of Technology, Surat, Karnataka, and we have Mrs. Sista and the team. They are going to demonstrate the various experiments in the virtual lab. I request Sista ma'am, please take over this.
Good morning, all. Myself, Vismaya, working as Senior Research Fellow in Redfall. On behalf of Virtual Lab team, I welcome all the faculty members of GoI Engineering College to the introductory webinar of Virtual Labs. So today we'll be showing you some of the labs, from computer science, electronics and communication, civil engineering and mechanical engineering. So I'll stop sharing my video and I'll start presentation. Hope my screen is visible.
Yes, ma'am.
Thank you. Yeah, you already had an introductory session on what we done an introductory PPT for you, which describes or discuss about all the things. That is an MoE, Government of India initiative under the National Mission. So there are various initiatives under this program like E-Yantra and so on. So virtual lab is one among them.
Ma'am, your audio is not clear, ma'am. So kind of breaking.
It's fine now, sir.
Okay, ma'am. You can go.
Okay. So virtual lab is one among them. So long years back, and the process is still going on. The virtual lab is to provide remote access to simulation of science and engineering. And when I say virtual lab is independent of space, place. So there is no time restriction or no requirement anywhere, even while traveling, he or she can use the virtual. You can find all the broad areas of virtual lab we have and two basic science domain labs.
Still, there is a problem with this, ma'am. Audio is not very clear. Please.
Hope it's fine now, sir.
Okay.
So moving down, these are the participating institute under virtual labs. We have 11 participating institute under virtual lab, which include 6 IIT, 1 IIIT Hyderabad, Amrita University, Belpark University, Suratkal and NITK Suratkal. So NITK Suratkal is the only participating institute. So clicking on each, be able to find on each institute logo, you can find all the virtual labs. These are the virtual labs developed by NITK Suratkal. Transportation Engineering Lab, Environmental Engineering Lab 1 and 2, and so on. So you can find. Moving back to the main page. could not find any labs or experiments that you are looking on. Do we have any other way to find it over here? Yeah, come back. Labs Dev button, click on that, which will take by IIT Bombay, where you clicking on that will give you 3 submenus: demonstration of labs under development. So clicking on approved labs, you will get many. So click on discipline, which will sort out you by discipline. Computer science engineering, electronics and communication, mathematics, physics, plastic and polymer engineering. Apart from this, we also have labs which are under development. So clicking on labs under development button, you will get many more labs. So sort out by discipline. Here in the labs under development also, you have labs from biotechnology and biomedical, computer science, electrical engineering, physics, forensic science, ballistics, heat transfer lab, and so on. So moving back to the main page. So if you are from circuit domain, the same concept lab will be from electronics and communication, computer science engineering, and also from physical sciences. And if you are from mechanical domain or onto both the domain labs for the same concepts. So today I communication domain labs. So clicking on each domain labs and the institute who developed these labs here in the. So first I'll be selecting the basic electronics lab. So clicking on each lab.
I'm sorry to interrupt. Your audio is not very clear, ma'am, because it's frequently breaking voice.
Fine, sir, now?
Yes, ma'am.
Sir?
Ma'am, you can go ahead. I will.
Just a minute, I will try with another.
Yeah.
Your presence. Yeah.
Is it fine now?
Sir, can you hear me? Yes, sir. 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 Yes,
No, ma'am.
Hope it's audible and clear now.
Their internet connectivity is weak. It's showing yellow.
Sir, can you check your network connection once again?
Now it's fine, ma'am. Now it's fine.
It's fine now.
Okay, I'll share my screen now.
Sure.
Yeah. So when clicking on to electronics and communication domain, you'll get all the labs under electronics and communication domain, and the institute who developed these labs are given here. So today I'll be selecting the basic electronics lab, which is developed by IIT Kharagpur. So clicking on each lab, you'll get an introduction, list of experiments, instruction, technology used, people, and a feedback session. So moving down, like in introduction part, it's all about virtual lab. This basic electronics virtual laboratory by IIT Kharagpur is an older lab. Under list of experiments, you will get around 17 experiments. So the number of experiments will be lab dependent. Under instruction of browsers are given, and the technology used, JavaScript and HTML5 are the technology used to develop this lab and the experiment. People who are involved in developing this lab, so you can contact directly them for any query related to this lab and the experiment. And finally, the feedback. So moving on to list of experiment, I'll be selecting the fourth experiment, which is the basic experiment, Ohm's law. So selecting each experiment, you will get a theory, procedure, simulation, quiz, assignment, and a reference. So for all the newer labs, the content will be different. Like it will be like aim, theory, procedure, simulation. For quiz, you will get a pre-test and post-test questions, and finally the references. So here in the theory, all the theory related to Ohm's law will be given. Here we have the Ohm's law triangle, equations, and explanation of Ohm's law given under theory part. Moving on to procedure, step-by-step procedure to do the simulation is given here in the procedure part. So for this experiment, first you have to set the resistance value, then you have to select the DC voltage. You will find the voltmeter is placed parallel to the resistor and the ammeter is placed in series with the resistor. So setting the DC voltage, you can note down the voltmeter and ammeter reading. Finally, with the values, we'll be able to plot the VI graph to verify Ohm's law. So moving to simulation, we have variation of Ohm's law given here. I'll select the first one. So here is the simulator interface of Ohm's law. We have the instruction to do the simulation given here, an experimental table, circuit, and the controls, and the 3 button, which is add to table, plot, and clear. So looking on to instruction, I'll select the resistance value first. Then you can select the DC volt. Click on to add to table button. So here you can find in the experimental table, the voltmeter, ammeter, and the resistance value are noted down. So keeping the resistance value constant, I'll take around 5 to 6 values of DC volt and click add to table. You'll find our experimental table is updated now. So to get the graph, click on to plot button. So with the given values, we'll get the VI graph. So to print this whole page, click on to the print button. And here you will get the save as PDF option also. So you can save it as PDF for the future reference. So to clear all these values, click on to clear button. So you can find here all the values are cleared now. Moving back, next is the quiz. We have some MCQ questions to test your knowledge. So you can click your answers and you can submit your answers here. So which will give you the right and wrong answers. Under assignment question, assignment also you'll get many more questions, and finally the references. So this is all about the basic electronics virtual laboratory. I'll take one more lab from electronics and communication domain. It's electronics, a digital electronics lab developed by IIT Roorkee. So for this digital electronics lab is a new lab. So we have the introduction, objective of the lab. Under list of experiments, we have around 12 experiments given. Next is the target audience, or for whom the lab is applicable for. So this lab will be applicable for BTech or PE in EC and MS or PhD beginners in EC and the related topics. And next is the course alignment or the syllabi used to develop the lab, and the experiment will be given here under course alignment part. Finally, the feedback. So here in the feedback session, you can share your experience, which will take around 3 minutes and which will help a virtual lab better for you and for others. So moving on to list of experiments, I'll select the first experiment. So selecting each experiment, you will get any theory, pre-test, procedure, simulation, post-test, reference, and a feedback. So aim of the experiment is given here in aim. And next is the theory. So here our experiment name is verification and interpretation of truth table for different logic gates. We have all the logic gates given under theory part, and logic symbol for each gates and the truth table are given under theory part. Next is the pre-test, some set of MCQ questions. So you can select your answers and you can submit your answers here. So which will give the right and wrong answers. So if the answer is wrong, it will be marked in red color. Next is the procedure to do the simulation given under here. So here we have two simulators. In simulator 1, we have to connect the supply first to the circuit. Then if the switch is on, it will be marked in green color, or if it is in off, it will be marked in red color. And if both the switches are on, the bulb starts to glow. And on simulator 2, we will be having an AND gate. We have to enter the Boolean input A and B and the corresponding output for our Boolean input. Then click on to the check button to verify your output. Finally, you can print the whole page, or you can save it as PDF. So moving on to simulation, I'll select the simulation of AND gate. As seen in the procedure part, we have two simulators, simulator 1 and simulator 2. So this is the simulator 1. We have the instruction given here. First, we have to connect the battery. By a single click, the battery will be connected to the circuit. So click on to switch 1. So here you can find the battery is connected. A message pop up here as connected. Then click on to switch 1. So the battery is connected to the circuit. Switch 2 for input A and switch 3 for input B. So here you can find the bulb starts to glow now. And the specifications of battery, resistance, and transistors are given here. Moving on to simulator 2, we have the AND gate. We have the instruction given here to do the simulation. We have to enter the Boolean input and the corresponding output for our Boolean input. So click on to check button to check whether our output is correct or not. So when clicking on check button, you will get here in the truth table input, output, and the remarks. So to reset the input and output value, click on to the reset button. So our values are reset now. Take another input and output values. Click check button to verify it's right or not. So you can take all the input and output value. And finally, you can print the whole page, or you can save it as PDF. Moving back, next is the post test, where you have to do it after the simulation to know the understanding level of your simulation. So click on the answers and submit your answers. So here you can find if the answer is right, it will be marked in the same color, and if it is wrong, it will be marked in red color. And the references or the resources used to develop the lab and the experiments are given here. And finally, the feedback. So that's all about the digital electronics lab developed by IIT Roorkee. I'll show you one more lab from electronics and communication domain. It's analog electronics lab developed by IIT Roorkee. So clicking on analog electronics laboratory, the contents are similar to digital electronics lab. We'll have an introduction, objective, list of experiments. So here in analog electronics, we only have 7 experiments under target audience. Like BTech and B in electronics and communication, and MS or PhD beginners in EC and the related topic. So this lab will be applicable for these peoples, and the course alignment, finally the feedback. So moving to list of experiment, I'll select the first experiment, log and anti-log amplifiers. So clicking on each experiment, you'll get a theory. So here in theory, we have the all the things about log amplifier and anti-log amplifier are given. Under pretest, you will get some MCQ questions. Next is the procedure. So to connect the probes, like all the procedure are given here. First, we have to connect the probes as mentioned below. Then we have to select input voltage, then the voltage across the output terminal, and increase the input voltage in step of 1 volt up to 20 volt. And finally, we can plot the characteristics of input voltage and output voltage. So moving on to simulation, I'll select the simulation of anti-log amplifier. So we have the instruction given here to do the simulation. So we have to connect the probes first as mentioned here. So to connect this, just drag and drop from the points. So L1 to L3. So looking on to instruction, I'll connect all the probes. So after connecting the probes, click onto the check button to verify our connection is right or wrong. So here we have a message pop up here as right connection. After checking the connection is right or wrong only, select input voltage will be active. Then you can select the input voltage, click on to the calculate button. So you'll get the output voltage here. Click on to add to table button to add it into the experimental table. So select input or drag input voltage, click calculate button to get the other output voltage value. Click on to output add to table button to note it down in the experimental table. So we can take around 5 to 6 values. Finally, you will get the graph here. Output voltage versus input voltage graph will be given here. So finally, you can print the whole page or you can save it as PDF for the future reference. So to reset all these connections, click onto the reset button. So next is post test. Some set of MCQ questions are given here under a post test also. Next is the references or the resources used to develop the lab and experiment. Finally, the feedback. So that's all about the electronics and communication domain labs. Here we have so many labs under electronics and communication. I request everyone to explore it. And under a development portal also, you'll get many more labs under electronics and communication. So that's all from my end. Over to you, Anusha. Thank you all.
Thank you. Good morning, everyone. Myself, Anusha Salian from Center for System Design and ITK. I hope I'm audible.
Yes, ma'am. Yeah.
Thank you, sir. I will be sharing my screen. I hope my screen is visible.
Yes, ma'am. Yes.
Thank you, sir. Broad areas of virtual lab, we can find computer science and engineering domain. I'll click on it. It will take us to the page where the list of labs related to CS domain are available, along with the name of the institute who have developed that particular lab. So first I'll start with the basic programming lab, then I'll move on to the advanced lab. First we'll see one of the experiment from computer programming lab, which is developed by IIIT Hyderabad. Here in this lab, we can study the different concepts related to computer programming, like arrays, linked list concept, some sorting techniques, etc., as well as functions, recursion, etc. So every lab has different sections like introduction, objective, list of experiments, target audience, and course alignment. So the introduction has the basic overview of the lab, and the objective has the goal or the aim of developing this particular lab, and the list of experiment has experiments covered in this particular lab, that is in computer programming lab. Similarly, target audience and course alignment has courses and the universities aligned to this particular lab. So I'll go to list of experiments. The different concepts of computer programming are covered in this lab. There are 9 experiments like numerical approximation, functions, advanced control flow, arrays, structures, basic control flow, pointers, recursion, and expression evaluation. In this list, I will demonstrate one of the experiment, that is arrays. So again, every experiment has different sections like aim, theory, pretest, procedure, simulation, post-test, references, and feedback. So this is the aim provided for the arrays experiment. And if I go to theory section, the brief theory or the introduction related to arrays concept is explained in detail with examples. So in the pretest questions, some questions related to arrays concept based on the theory given are given here. If I go to procedure section, the procedure is provided. There are 2 different experiments in this. So for both of the experiments, the procedure is provided here in this in the procedure section. I'll go to simulation section. So here we have 2 options, 1D array or 2D array. I'll go with 2D array. This is the interface. So the main intention of computer programming lab is to make the student understand the tracing of the program. So we have 3 tabs here: initialize, step execution, and code output. So code output is divided into 2 more sections like matrix and resultant matrix. So first step here is to enter the matrix size. Here we are going to perform the matrix calculation. So first we have to enter the matrix size, the first matrix, and click on OK button. And to generate the values for A, click on generate values for A. The simulator will give the values for both the matrix. Now we have to click on we have to choose the matrix size for second matrix. And again click on OK button and click on generate values for B. Now to start the simulation, click on start button. We'll get the appropriate program for calculating matrix multiplication under the step execution tab. And in the code output section, the matrix elements for both the matrix values for both the matrix, that is matrix A and B, is provided here. So the resultant this is the resultant matrix for now. So I'll click on next button to start the execution of the simulation. I'll click on next button. You can see observe the changes in the step execution tab. I'll click on next button again. So the red color line indicates the line which is being currently executed. So currently this line is being executed now. I'll click on next button. Now we have entered the loop. So the matrix elements are selected. Similarly, second matrix column is also selected. Now the matrix multiplication begins, and we can observe the change in the resultant matrix as well. The result is highlighted in a brown color here in the code output section. Similarly, we have to keep pressing next button until the end of the execution. So in this way, we can study the tracing of the program. I'm clicking on next button here, and we can see the observe the changes in code output section. So until the end of this execution, we have to keep clicking on next button. So the execution has finished. We can see the pop-up message that is code running is over. I'll click on OK button. So the entire page will reset. So this is a procedure followed in 2D arrays. Similar procedure is followed in 1D array also. Please explore the 1D array section of arrays experiment. So I hope you understood the procedure. So the next section here is post-test, which has questions based on the simulation part, and similarly reference has references or the additional reading materials for arrays experiments. So this is about arrays experiment. There are 8 more experiments. Please explore the other experiments of this lab. Almost all the experiments follow the similar procedure. So this is about computer programming lab. I'll demonstrate one more lab. So there are many more programming labs here available here, like problem solving lab, which is related to C and C++. Similarly, there is one more lab that is Python programming lab, which is related to Python, etc. So we will move to the advanced lab now. So data structure is one of the major subjects. So there are 3 labs which covers different concepts of data structure. That is data structures 1, data structures 2, and data structures lab. All the 3 labs are developed by IIT Hyderabad. I'll demonstrate one of the experiments from data structures lab. So we have seen these sections for the previous lab. So I'll go to the list of experiments. So these are the experiments covered in data structures lab. Expression evaluation using stats, sorting techniques like merge and quicksort, polynomials via linked list, and tree concepts and graph concepts. Search tree, expression trees, graph traversals, that is depth first search and breadth first search, and shortest paths in graphs, and minimum spanning tree. So I'll demonstrate minimum spanning tree experiment. So this is a minimum spanning tree experiment. Compared to the previous experiments we have seen, this particular lab has some additional sections like overview, recap, and some sections related to particular experiments, etc. So we'll see one by one. So aim has estimated time and the learning objective of the experiment. So the overall time required to perform the experiment is given, that is 1 hour, and the learning objective of the experiment, that is here we are going to study 2 different algorithms, that is Kruskal's and Prim's algorithms, to find the minimum spanning tree. Using these 2 algorithms, we are going to find minimum spanning tree. I'll go to the overview section, where there is a video which helps us to navigate through different sections of this lab or this experiment. And along with this, the prerequisites part of the experiment and the overview of the experiment and experiment weightage and modules are provided here. So I'll go to the next section, that is recap. So recap provides some basic information or the theory related to sorting and unsorted and types of sorting and unsorted arrays, and time and space complexity, and some information related to trees and graphs and types of graphs. So I'll go to the recap algorithm part. The algorithm related to the recap section is provided here. Here in the recap algorithm part, one more algorithm is explained in detail with example, that is union find algorithm. So again, the pretest has the questions based on the theory part. So I'll go to the next section, that is MST. the main section of this experiment, which is subdivided into aim and overview. Aim has estimated time to perform this section, and the observation based on the MSD is given here. So overview has some information or the theory related to minimum spanning tree along with example. So I'll go to the Kruskal's algorithm section. So Kruskal's algorithm and Prim's algorithm are the two algorithms covered here in this experiment. So Kruskal's algorithm is divided into aim, concept, algorithm, demo, practice, exercise, and quiz section. So the procedure followed in Kruskal's algorithm and Prim's algorithm is similar. So I'll demonstrate only one section here, and the procedure followed in analysis of Kruskal's and analysis of Prim's is also similar. So I'll demonstrate the analysis of Kruskal's part here in this session. I'll start with aim. So aim again has estimated time and the learning objective of this module. And I'll go to concept. The theory behind Kruskal's algorithm is given. How to find minimum spanning tree using Kruskal's is explained in detail with example. So if I go to the algorithm section, the algorithm part of Kruskal's is given here. And there is a video also which helps us to understand the finding of MSD using Kruskal's in a better way. So I'll go to the demo section. So in data structures lab, we have 3 or 4 places where we can perform the experiment. That is demo, practice, and exercise in this lab experiment. I'll go to the demo section first. So there is no separate section for procedure. Here in the simulator page itself, we will get the instructions. Click on instructions tab. We will get the instruction here. So this is the graph for which we have to find the MSD. And here are the control buttons: start, new graph, reset, and pause. To get a new graph, we can click on new graph button. Okay. So this is a graph for which we will find the minimum spanning tree using the controls. So we can set the speed of the execution also. I click on start button. So all the edges are in black color now in this graph, which indicates that the edges are not visited. I'll start the execution by clicking on start button. The smallest edge will be selected first. Smallest valued edge will be selected first. This is the smallest valued edge, so it is selected. Now the edge has been turned from black to blue, which means edge is being checked. Now it is turned to a brown color, which means edge is added to MSD. And at each step, we will get the instruction under the observation tab. So currently this edge is being checked and it is turned to a brown color, which means that it is added to MSD. So the next smallest valued edge is this. Let's see whether it will be added to MSD or not. We can see observe the instruction in the observation tab. This edge has turned to gray color, which indicates edge is discarded because it forms a loop. As per MSD, it should not form, any edge should not form a loop. So this also can be added. Now this edge will be checked. I'll increase the speed of the execution. So it turned to brown color again. And we can see the instruction in the observation tab. Now only last edge is checked. Now, so the execution has finished. This is the MSD for the given graph. So to reset the entire page, we have the option here by clicking on reset button. We can reset the graph and start the execution from the beginning. To get a new graph, we have the option here. So this is the procedure followed in the demo section. Almost similar procedure followed in practice and exercise section also. Only difference is here in this in the practice and exercise section, the users can choose the edge using their mouse. And again I have clicked on this edge and it turned to brown, which means it is added to MSD. So I have clicked on this edge, which is a wrong edge, and it forms a loop. So it will be the simulator will not allow us to add it into the graph. So in this way, we can perform the experiment. So I hope you understood the procedure of practice part. I'll go to the exercise section. Almost similar procedure is followed here. Here also the users have the option to choose the edge, and we can submit after choosing the MSD to check to verify whether the submitted MSD is correct or not. So the next section is quiz. The quiz section has questions based on the crystals algorithm part. I'll go to the analysis of crystals. So again, it is divided into aim, time and space, complexity, and quiz. So aim has estimated time and the learning objective of the module, and time and space complexity has running times of crystals, best and worst case of crystals, and space complexity of crystals. So again, it has quiz section, which has questions based on the analysis of crystals section. So these are the sections related to crystals. So we can find Prim's algorithm and analysis of Prim's. As I said before, please explore these two sections. So post-test has questions based on all these sections, and I'll go to further readings or reference section, which has additional reading materials. So this is about minimum spanning tree experiment. I'll go to data structures 2 lab, which where we can find the experiments related to data structures 2. Some sorting techniques, graphs, search tree, strings are covered in data structures 2 lab. So please explore the other experiments and the other labs of covered in computer science and engineering domain. So these are few of the labs, and here we can find cryptography lab, which is related to information security protocols and etc. And so computer architecture and organization lab is related to logic design concepts, and computer organization lab covers microprocessor and microcontrollers labs. So these are few of the labs available under the virtual lab main portal. There are few more labs in the VLab development portal, like Java programming, object-oriented modeling and design, database lab, computer graphics, computer networks, and some web technologies concept like PHP, JavaScript, etc. So please explore both the portal, VLab development portal, as well as VLab.co.in. That is the main portal of virtual lab. So this is from my end. I'll end the session from my end and hand over the session to the next presenter, that is Karthik. Thank you, everyone. Over to you, Karthik.
Okay, thank you, ma'am. Okay, I hope I'm audible.
Yes, Karthik.
Yeah, thank you. So good morning, everyone. My name is Karthik Shetty. So I'm currently working as a junior research fellow in Center for System Design at NITK Surathkal. So let me share my screen. So I hope my screen is visible.
Yeah, visible.
Yeah, thank you, ma'am. So today I'm here to demonstrate labs under mechanical engineering domain. So in this screen, you can see the home page of a virtual lab. When you scroll down, you will get broad areas of virtual lab. Under this, you can find a mechanical engineering domain. So once you click on that, you can see one more page where we can see various labs under a mechanical engineering. So these are the labs which are developed by different institutes like the Albag, NITK Surathkal, IIT Kanpur, CoE Pune, and so on. So you can find the labs like 3D printing, dynamics of machine labs, FAB labs, machine dynamics and mechanical vibration labs, So you can explore these labs. So I will demonstrate dynamic of machine lab, one of the new lab which is developed by NITK Surathkal. So this interface is for dynamics of machine lab, and the interface is similar for each and every experiments as well as labs. In the left side of your screen, there will be a navigation tab like introduction, objective, list of experiment, target audience, course alignment, and feedback. So this navigation tab is similar in each and every labs. So first, in the introduction tab, some basic information about the dynamics of machine lab has been given here. Next is the objective about the dynamics of machine lab. So next part is a list of experiments. Next is a target audience, course alignment, and last is a feedback. So in the target audience part, so this lab is applicable for BE, BTech in mechanical engineering, automobile, mechatronics, and etc. And also this lab is applicable for postgraduate students. Next, in the course alignment, the syllabus of this lab aligns to the following universities in India. So the universities are listed below. In the feedback section, you can share your experience about the particular lab. So now moving on to the list of experiments. So under dynamics of machine lab, there are total 9 experiments. The experiments based on dynamic analysis of 4-bar mechanism and slider crank mechanism. And you will be having 3 experiments on governors like Proel, Porter, and Hartnell governors. Then 2 experiments based on balancing of multiple masses in a single plane and a multiple plane. Then other 2 experiments are flywheel experiments, that is a disc type and a rim type flywheel experiments. So today I will demonstrate a Hartnell governor experiment. So in the screen you can see the interface. In the left side of the screen, there will be a navigation tab like aim, theory, pre-test, procedure, simulation, post-test, reference, and feedback. So first is the aim. So aim of the Hartnell governor to visualize the working and effect of speed change of a Hartnell governor to a simulation. So this will be the aim for Hartnell governor. Next part is a theory. So in the theory portion, what we have is some basic information regarding the particular experiments. Any user who wants to learn from the basic level can go through this portion. So in this portion, there will be some images and required equations has been listed here. We can take a help of this. After completing theory, you can move on to a next part, that is a pre-test. So in this portion, we will be having some MCQ question with respect to the particular experiment. So you can answer these questions and check your level of understanding. So you will be given some questions and each questions has 4 options. You need to select a right option. So for example, I will select some arbitrary values, arbitrary answer. So once you select the right option, you can submit your quiz. So the score will be highlighted at the bottom. So out of 8, my score is 4. If you made any wrong attempt, it will be highlighted in the red color, as you can see over here. So if your answer is right, the color will be same, that is a black color. If your answer is wrong, it will be highlighted in the red color. So once you complete pre-test, we can move on to a procedure part. So in the procedure tab, you will be having a detailed description of how you have to conduct a simulation in the simulator. For a user who is new to the particular website, can go through the procedure and get better idea to the various stages in the simulation. So it will help to how to conduct how to perform a simulation in a simulator. So after completing theory pre-test procedure, you can move on to a simulation part. So in this screen, you can see the simulation window of a Hartnell governor. So this white color part is called as the animation section. In the right top corner, we'll be having a variable toolbox section, and at the bottom is a control toolbox section. So in the animation section, we have a Hartnell governor setup. Next to that, there is a free body diagram for a minimum position. So if you want to change the free body diagram for the maximum position, in the control toolbox section, there is one option called as, there is a two option. So now it is in the minimum position. If you want to change for a maximum position, just click on the second option. So the free body diagram has been changed for the maximum position. So you can change in the variable toolbox section, you can change the mass. So you can observe in the animation section, there is some slight changes in mass. And you can change the speed of the governor. Now speed is increased. And the stiffness spring value is given over here, and lift off sleeve is also given in the display section. Now click on go to experiment. So we will be having a two option, that is the calculation part and identifying the parts of governor. First click on the calculation part and click on start experiment. So first calculation is for free body diagram of a minimum position. So first is the stiffness of the spring. You have to calculate. The formula is given in the theory part as I shown before. So now I will select some, now I will enter some arbitrary value and click on check. So if your answer is wrong, don't worry. At the bottom, the correct answer will be displayed. You can see here, the stiffness of the spring is 18.59 Newton per mm. Next is a radius of the rotation. Check. Next is a lift off sleeve. Then the constant variables is given over here, that is x and y value, omega1, omega2 value, r, r1, r2 values. So once you complete calculation of free body diagram for a minimum position, next click on next option, that is a calculation for a maximum position, and reset the experiment. So now you can calculate the value for the stiffness of the spring. So once you complete calculation part, you can exit. So here we completed the calculation part. After completion of calculation part, you can exit the experiment. So you will be having one more option, that is identifying parts of governor. Click on that. Start experiment. So here we have to find each and every parts of the Hartnell governor. So each part has some options, drop down options. You can select right option. So this green color part is called as nut. So if your answer is correct, you will be getting a right option. If your answer is wrong, suppose like, so if your answer is wrong, it will be displayed as the wrong option. Next part is a collar. So this part is called as a roller, spindle, sleeve, bevel crank lever, the ball, spring. So by this, we can identify each and every parts of the governor by using drop down menus. So here we completed the simulation part. You can click on exit experiment. So this is all about simulation part. Next tab is post test. So it is similar as a pre-test. You will be having some MCQ question. You need to select a right option, and you can submit your quiz. Next is a reference. So in this section, we will be having various code books and textbook that we have referred in the development of a particular experiments, and we will be having a contributor list. And last is a feedback, where you can share your experience about a particular experiments. So here I end my session and hand over the next session to next presenter, that is Ashika. Over to you, Ashika. Thank you, everyone.
Good morning, everyone. My name is Ashika Pai. So I'm working as a junior research fellow in Center for System Design and ITKS. I hope I'm audible.
Yes, ma'am.
Yeah, thank you. So let me share my screen and let's move forward in the presentations. I hope my screen is also visible.
Yes, ma'am.
Yeah, thank you. So as explained by my colleagues, this is the website that we have to go in, that's vlab.co.in. So when we come down, we can see the various broad areas under which we can, we have different labs that have been developed. So today I'll be speaking in depth about the civil engineering labs. So we just have to click on civil engineering, and then we'll be getting the various labs that have been developed under civil engineering. So today let's look into some of the experiments in these labs so that we'll get to know the interface in a better manner. So for now, let's look into one of the experiments in strength of materials lab. So the user interface for all of the labs in civil engineering is almost similar. So at the left hand corner, we'll be having our lab. So now we can see here we have the introduction. Next, we have the objective. And here we have the list of experiments. So here a total of 14 experiments have been listed. Next, we have the target audience. So here we can see who are the students that will be benefited by the development of this lab. And then in course alignment, we have the subjects of various universities where you can find the concepts that have been there in these experiments. So without wasting any much more time, let's look into any one of the experiment. So now I have selected direct shear test on mild steel rod as one of my experiments. So again, here in the left hand corner, we have our navigation tab. So in this page, you'll be getting all the information regarding one particular experiment only. So we have the aim, and next we have the theory. So in the theory portion, you'll be having all the basic concepts regarding this particular experiment. So if a student is new to this concept, they can look into this material and they'll come to know much more about the concept and why this experiment is being conducted. Next, we have the procedures tab. So in this procedures tab, there is a detailed description of how the simulator will be and what you have to do in various steps in the simulator so that you'll be able to conduct your experiment. So rather than the normal procedure of the conduction of the experiment, in this procedure tab, we have the procedure of what you have to do in the various portions of the simulation so that you can conduct the experiment virtually. So that's about the procedures tab. So then we have two important tabs, that is the self-evaluation and quiz. So in both these tabs, you'll be having some MCQ questions which are in line with the topic. That is, all these questions will be regarding the direct shear test on Mansfield Road. So I would request all of you and even the students, when they are learning, it's good that they answer these questions so they'll be able to increase their knowledge base regarding the same topic. Now we can move on to the simulation. So now once I click on the simulation tab, the simulator page will get activated and my navigation tab will get hidden. Next, now we can conduct our experiment. So now we can see what is the objective and the apparatus used. After we have done this, we can click on the next button. So now even inside the simulator, you will be having guidelines which will tell you what you have to do in various steps in the simulation. So now here we have a written guideline that tells we have to take the milestone rod specimen and determine the diameter of the specimen using the vernier calipers. Similarly, we have the guiding arrows as well, which will tell us what we have to do in each and every step. So now what I have to do is I have to click on the specimen to find out the diameter. Now once that is done, I can click on the next step. So now here also you can see we have the guiding arrows which tells me what I have to do and where I have to click. So now once the shear attachment is placed back into the UTM machine, I'll click on the next button. So now once the instrument setup is done, we'll start the machine and we'll wait for the specimen to fail. We'll note the failure load and we'll stop the machine. So now once we have the failure load, we will get the first set of data. So we know what is the diameter, we can find out area of cross section. We have written down what is the failure load, by which we can find out double shear strength of the specimen 1. So similarly, we'll be conducting the same procedure for 2 more trials. So the basic idea why 3 trials has been provided is, one is to replicate actual physical lab conditions, and also one more thing is we have to get a nominal value which will represent mild steel as a whole. So now here we have failure load of 1600 and again we have the tabular column for trial 2. So the same procedure has to be followed for the 3rd trial as well. So now once again we'll start the machine and we'll wait for the specimen to fail and we'll stop the machine, and again we'll be having the trial 3 values. So now when I click on the next button, this is the place where we have to calculate the values. We have all the required parameters over here. We just have to substitute it and find out the answers. So for now I'll be entering arbitrary values over here, and let's see my accuracy. So when I give check, we can find out what is the actual value, what is the entered value, and what is the percentage of error that I have committed in conduction of the, or in calculating the value. So by this, the student will be able to understand where he is going wrong in calculating the value itself. So that's all about the simulation for this particular experiment. Similarly, there is one more important tab, that's the videos tab. So in this videos tab, you'll be provided with 2 demo videos. So one is the experimental demo video and one more is simulation demo video. So all these videos have been developed by under the initiative of Laghu Pata, and it's done by CSD in NITK Surathkal. So when you click on this, you will be directed towards a YouTube video link where a detailed video description will be provided. So in the experimental demo video, you have a detailed video description of how this particular experiment is conducted in a physical lab. So if a student is not able to attend the lab or has some doubts regarding the physical experimentation, they can look into this video and they'll get a very clear idea of how the experiment has to be conducted. Similarly, even in the simulation, if you're facing any difficulties to conduct the simulation, then you can look into this video. Here, a detailed video description is also provided of how we have to conduct the particular experiment in the Virtual Labs website. So next we have the references tab. So in the references tab, you have all the codes and textbooks that have been referred in order to develop this particular lab, and also we have the contributors list. So now that's about one of the experiments in strength of materials lab. Similarly, I request the participants to please go through the other experiments in the lab as well. So now I'll be taking you to one of the newer labs, and there are some minor changes that have been done in the newer lab so as to make the Virtual Labs website even more effective to its users. So now here the user interface is almost similar. We have the objective, list of experiment, target audience. So nothing has changed in this aspect. So now let's directly go to the list of experiments and let's select one of the experiment. So now here again the user interface is almost similar. You have the navigation tab at your left hand corner. There was something called as self-evaluation and quiz in the older labs, but in the newer labs they have been renamed as pre-test and post-test. So they are the same MCQ questions, but just their names have been remodeled. Next we have, and then as usual we have our aim and theory. So even in this newer lab also, the theory will provide the basic information regarding the particular experiment. And in the procedures tab, you have a detailed description of how you have to conduct the experiment. So the basic idea of why this is being provided is if the student or the learner is new to the website, then they can they'll come to know what is the interface that they are going to face in order to conduct the experiment. Sorry. So next, we can move to the simulation. So now inside the simulation, there are some new features that have been added into the simulation. So one is the description. So when I hover over the description icon, I'll get a pop-up message that tells that pH is a term used to express the intensity of the acid or alkaline condition of the solution. It's a measure of hydrogen ion activity in the solution. So this is basically a very concise form of what is pH. So in the theory portion, we'll be having a very elaborate explanation of the concept. But in the description, we have a very concise form of what this experiment is going to find about. So after we have looked into these parameters, we can click on the next button. Okay. So now we have to select one of the given samples. So now let's select seawater as my sample and we'll click on the next button. So first we have to do the calibration of the pH meter. So first we'll be using the distilled water to clean our temperature and electrode probes, and then try using the tissue paper. So when I give OK, the particular command will be executed. So now you all can see there is a pop-up message that has come in the simulator interface. So without answering this question, I cannot move forward in the simulation. So the basic idea why this has been introduced into the virtual lab website is to make the simulation even more interactive with the students, and at the same time they'll be able to gain more knowledge regarding the subject. So now we'll place the buffer solution of 7 and calibrate the pH meter to 7. Again, I have come up with another formative question which I have to answer, and then only I can move forward. So again, we'll be cleaning the temperature and electrode probe. So the basic idea why this is done is there shouldn't be any discrepancy in the next reading that we are going to take because of the previous solution. So now here another formative question has come up. The pH is a measure of hydrogen ions, and then we can move forward. So now the buffer solution of pH 4 is kept and the probes are inserted into it. So now the pH meter has got calibrated. So now what is remaining is we have to determine the pH value of the sample. So again, we'll be doing the same procedure, and then we'll give OK. So now again, we have to answer this question. So I hope you're able to get to know that with the formative questions, it has been even more interactive during the simulation. So experiment, you'll get to know about it in a much better way. Then we'll click on the next button. Now we have to place the sample that we had chosen in step 1 and dip our probes. So now we have found out the pH of seawater is 8.3. So now we have to give the inference that if the pH of seawater is 8.3, what is the nature? So it's alkaline. So next we have the inference that if the pH is less than 7, it's acidic. If it's 7, it's neutral. And if it's greater than 7, it's basic, or also called as alkaline. So now that's about the simulation for this particular experiment. Next, there is one more change in the newer labs. That is, in the older labs, we had a dedicated tab for the demo videos. Other than that, the same videos have been inculcated in the references tab. So you'll be finding your YouTube links for the simulation demo and the experimental demo video developed by Lagupata in the references tab, along with the IS codes and textbooks, and also the contributors list. So that's all from my end. Please stop sharing my screen. Over to you, Vismaya.
Yeah, thank you, Ashika. So we had came to the end of the presentation from our end. Query, they can ask it right now. They can put the query in the chat box, or they can unmute the mic and ask.
Ma'am, the students can directly get into that URL and they can start explore the experiments, right? So no need to have any credentials for the students and faculty.
No, sir. They can directly log into VLab's website and they can start exploring the labs and experiment.
Right. Ma'am, one professor is looking at me because only a few disciplines are placed in the virtual lab. For example, we have a textile department. We don't have any kind of the courses in it. It's only limited some 8 different disciplines we have seen virtual lab site. So, is there any other disciplines included in future, ma'am?
So actually, like labs from other departments, like labs from other domains are under development. You can in the VLab development portal also. So after development, it will be finding in the main website.
Any other queries? Ma'am, thank you very much. We had a great insight of the different labs and especially from different disciplines. Thank you very much. My sincere thanks to Vismaya ma'am, Anusha ma'am, Karthik Shetty, and Ashika ma'am, and also my sincere thanks to Mrs. Sista, who is coordinating with me for conducting this demonstration. And on behalf of our college, thank you all for your great session. So thank you all.
Yeah, thank you for giving an opportunity on behalf of virtual lab team. I request every participants to well, like your students also. And I have put the feedback form in the chat box. I request everyone to fill the feedback form. And if you have any query, you can write to us at solve@nitk.edu. Thank you all.
Thank you. Thanks.